Friends, in the last session, we talked about last few sessions, we talked about load balancer, auto scaling group, how it works, and a very important topic. If the application is deployed in the VM, right? We have the applications could be deployed in the containers also. We will talk about that. That's the next topic, not today. The next week we'll start with containerization. The application could be deployed in the containers as well, and we'll see how do we auto scale, load balance, and things like this. But what we have covered is the load balancing for the VMs. So we are assuming that the application is deployed in the VM, virtual machine. And we understood how the load balancing and auto scaling group works. So today we'll talk about databases, friends. Let's understand about cloud databases and how do we make sure on the performance wise, on the high availability wise, what the features of cloud database. We'll talk about that. That's the agenda for today's discussion. We have a slide, friends. Let me go to the PPT. We go to the Google Drive. If you go to this folder, SRE folder, you would see there's something called databases, right? So that's what we're going to explore today. OK, see now, what is a database? Why do we use database, friends? Let's start with that first basic understanding. Anybody?
It is used for storage.
OK, we have storage. That's good. Storage. Database. So we are maintaining some sort of database, some repository or some information we are accumulating database, base of the data, database. OK. See, if you go 30 years back, if you visit a bank, let's say 35 years back, if you go, they don't have a digitization. They didn't have. If you have to, let's say, deposit some amount or withdraw some amount, you will go to the bank, visit the bank, and they will open a physical register, physical notebook, and they would make the entry of deposit or withdrawal, and you would get the amount. And you need to visit the same bank. Interconnectivity was not there between the banks. Like, those were the things. Now, when the digitization came, software evolved, right? We were using Excel to store information. Again, but when we talk about the dynamic applications on the websites, web applications, the Excel sheet or physical notebook will not help, right? Because we need the data on the fly. When the user does something in the UI, in the web page, web server, in the browser, we need the data, right? If I go to Flipkart, Amazon, I would like to search the products. I need all the information. I need to do the billing. My order ID has to get stored somewhere. When I to log in, it has to authenticate. My credentials has to be stored somewhere. It should load my profile with my address and everything, my profile, whichever I have put in the wish list. It will have all those information. So where do we store all the information? We need the database. We need all information stored in the database. And that's where we talked about database, friends. Now, there could be multiple ways you can use database. Now, let's talk about the role of a DBA, database administrator. When the DBA is working on-prem, you know, right? We have to set up our own infra, right? We have to purchase the physical server, virtualize it, and then we create the VM and we go about database installation. So look at this, the role of a DBA in the on-premise setup scenario. Look at this. So DBA has to perform so many tasks. So first of all, obviously the power, like cooling, and internet rack, stack maintenance, server maintenance. On top of that, OS installation, OS patches, then database installations, database backup, high availability of the database, scaling of the storage, app optimization. So DBA has these main responsibility in the on-premise setup because you have to get the server, do the virtualization, and then on top of that, you create the VM and you go about database installation and then database tasks, backups, database software patches, scaling, high availability, app optimization, SQL tuning, right? Now, when you move to cloud, let's say when you use EC2, lot of things, right? The OS installation is taken till OS installation, virtualization is taken care by the cloud. Yes or no? Do we install OS ourselves in the cloud if you go to EC2 instance?
No.
No.
We simply select it and that's it. So if you look at the cloud setup, let's say when I use the EC2 instance, so a lot of work is done by the cloud. We don't need to worry about getting the server, OS installations and all. I can directly start my work from here. The DBA can start the work from here. OS patches, upgrades, like app update I do, right? Update the OS, some security vulnerability patches, database installations, database backup. We have to high availability. The database is highly available. Even if one database down, you have a backup or standby database. So they have to set it up. The DBA has to set up all these things. Now, most of you would be working like this. How many of you work in this setup? That you create the EC2 instance from the cloud and install database.
Yeah, I work in this kind of setup, sir. In
This
EC2.
setup, EC2 setup. Now we have a third category. First was on-prem, second was EC2 from the cloud, and then we have a third category called managed database. Cloud offers managed database where cloud takes care of all the mundane stuffs. See, OS, when cloud can give you a server, install the OS, why can't cloud can automate the database installation part? Doable? Yes or no?
Yes.
When cloud can give you an OS installation automation, and they give you options to select and all. Similarly, even the cloud can give you option to select, okay, which database you want, okay, Oracle you want, MySQL you want, Postgre you want, and they can install things for you. They can automate that backup also, hourly backup or daily backup. They can automate that process also. So lot of things. So in the managed database offering, lot of such work is done by the cloud. And that's why it is so popular. All the mundane stuffs which could be automated has been optimized, has been automated by the cloud itself. You don't need to do anything. We just need to select, okay, I need this database, this configuration, this CPU, this memory, that this is my admin credentials, create database. You have to pay, but they will give you all these features. You don't need to worry about taking database backup or maintaining high availability, storage, auto scaling. As a user, you need to fully focus on the app optimization because it's your application. Indexing, SQL tuning. It is your customer responsibility of doing the app optimization. And that's what we're going to learn here. Because we have offerings. If you go to the cloud offers you all sorts of database. You have all the possible use cases, that you have, not just the relational database. We have non-relational database also. In non-relational, we have various types also. All the offerings are there. All of these are all managed database. You just need to go there. Let's say if I select relational database, everybody is aware of relational database. MySQL, Postgre, Oracle, SQL Server, MariaDB, IBM DB2. These are all examples of the relational database. If I go here, if I go to RDS, relational database, Aurora is the AWS offering of relational database. They have developed on top of Postgre or MySQL. Aurora is from AWS. They have optimized MySQL and Postgre. Aurora is option up to in two options we get Aurora. If you go to the databases, all you have to do is create the database. Simple. And select whatever you need. As I told you, Aurora has two options, MySQL compatible and Postgre compatible. And we have various other database, relational database, MySQL, Postgre, MariaDB, Oracle, SQL Server, DB2. You can select whatever you want. Give the database name, anything name you can want. You give your credentials. How do you want to log in to the database? You give the server sizing. What should be the capacity, the score, and the RAM? You just mention it. Like how do we get EC2 instance? We mention it. Do you need high availability or not? Just check this option. You just provide all the options. At the end, you click on create database and there will be monthly charges and that's it. They will automate the entire stuff for you. That's the managed database offerings. Is the difference clear? On-prem, EC2, managed.
Yeah.
Yes.
Now, the databases could be of multiple types. We have relational and non-relational. What is the difference between relational and non-relational, friends? What is the difference?
So in relational database, one table will be connected to multiple tables. Like if we take an example of employee table, it will be connected to his HR table.
So there has to be some relation between the tables, right?
Right.
Relational, as the name suggests, relational. Okay. And in relational database, obviously tables will be connected. Yes, go ahead. Are there anybody else? Okay. What is the specification of the table in the relational database? Let's say a table has these many columns. Let's say employee table. You have these many columns, let's say. If you're making an entry, you have to fill all the details. Yes or no? It's mandatory. If you do not have, you can mention it null, but you have to specify that. So we have a fixed schema. Tables have fixed schema in relational database. Can we say that? It has a fixed pattern.
Yeah.
Yes.
Right? So tables have fixed schema and tables have relations in the relational database. What is non-relational? What is non-relational? NoSQL database that we call it. Think about it, friends. I have a desktop here, monitor. The specifications of the monitor and the specifications of the watch. Do you think I can put those information in the same table? Is it possible? Do we have similar columns? Do you think so?
No.
Not at all, right? The specifications of a monitor would be very much different. Look at this specifications, model name, this display, right? Screen. I have a totally different description. Can I fill this? If I buy a slipper, do you think I can have the common columns?
No.
What do I mean? If we are adding the inserts, the records, all the records have the same specifications in the relational database. If I'm writing an employee table, all the employees, those who are joining the company, have the same specification, same column we have to fill in. But is it possible to store this kind of information in a relational database? Can all the product items, can we put that in the relational database?
No.
Not possible. So this we use document database. We store this information in the JSON. Could be XML, JSON, right? So relational with document database. So to store this kind of information, we cannot use the relational database. So we have to use other than relational database, non-relational database like MongoDB, Cassandra, right? I have to talk about these things. So one of the simple examples I would say, friends, the product items, I would say product items that we store. The product. So one of the examples of the relational database would be, look at this, friends. If you see this relational database fixed schema, tables have fixed schema, and all we don't have fixed schema. So like the product details, right? In a retail website, product details, store product details in a retail website could be the example. We have lots such examples where we cannot put in the fixed same schema, that they fall under non-relational database. Yes. Examples of relational database could be MySQL, SQL, Oracle, Postgre, and here MongoDB, DynamoDB, Cassandra. See, for database, for any storage, which two metric are the most important metric, friends? We have been discussing about EBS, EFS, right? Which is the most important metric for in the storage domain? What do you think? What you have heard me speaking most often? The metric for the in the storage.
Disk.
Yes, that's fine. But what is the metric? IOPS, right? IOPS. That's what matters. So we only perform two actions. In the storage, we only perform two actions. Either we read data or we write data. How fast we read data, like select queries, and how fast we write data could be insert, update, delete. That determines the how performing my database, how best performance of the database. If I have better IOPS, obviously I will be able to read fast, write fast. My database query would take longer, lesser time, response time. If I use SSD, it will be better if I compare to HDD. If I use HDD, my response time would be even become slower. Just by selection of the infrastructure, HDD response time would be slower. Yes or no?
Yeah.
Simple. So IOPS plays a very important role. So we need to be very careful. And we always use SSD. Okay, we always use SSD. In even our laptop, we use SSD. EBS is what we recommend. And that was the use case of EBS. What are the two use cases of EBS? What are the two use cases of EBS, friend, that we have discussed?
It's block storage.
Yeah, that's the EBS. That's the full form you're saying. What are the use cases? What do we store there? Why do we use EBS?
With data, so we keep that kind of.
Simple, I told you, right? Boot volume. Don't forget these things. Boot volume and the databases. That's what I told you. We store our operating system there, and we use EBS for the databases. Yes or no? That's what we discussed, right? Look at our laptop. Don't confuse. Don't remember these things. Where do you think you use SSD? You use SSD for your operating system? Yes or no? Do you use a HDD in your laptop?
Yes, we use HRT.
Do you use HDD or do you use SSD?
I mean, for storage, HRT, and for
For your laptop, what do you use, Kiran? Do you know this? It's HDD or
SSD.
SSD? SSD. That's what we discussed in the EBS, right? So many IOPS we have, GP2, GP3, IO1, IO2. We discussed so much of things about IOPS and throughput. So the EBS we use for the boot volume to store our operating system. Whenever we create EC2 instance, the disk that we use is nothing but the EBS volume. And if we need to install database also in let's say EC2 instance, we will get EBS volume only to store our database because it's higher, better IOPS. Right, friends? Are we clear so far? Everybody on the same page? So far, so good?
Yeah.
Yeah.
So if I talk about AWS, we have multiple options. And look, it's not about the AWS. AWS is this column, the right column here on the AWS service. These are generic things. So you need various kinds of database, relational database, depending on the use case. What type of data are we storing? It all depends. What type of data I'm storing? If it's a relational database, fixed schema, we go for relational database. Use case could be traditional applications, ERP, CRM, e-commerce. We use so anywhere, any company, any industry, relational is always the case. We always use relational. Apart from that, we also use non-relational. If you want to store something as the key value pair, key value, just the key and the value, key value, key value. We have a lot of options. In AWS also, we have DynamoDB. But there are other databases also which supports key value. High traffic web applications, e-commerce systems, gaming applications, we use key value pair. Now, you might have heard of caching. In our laptop, where do we cache operating system?
RAM.
RAM. Why do we do that?
For
To make it
faster
fast, right?
response.
Similarly, we have in-memory database. You can also cache you can use the master database as MySQL or could be NoSQL databases, non-relational database, but we want to make it fast. I want to make performance better. We use caching. We cache things. So those are caching happens in the RAM. Fast, better IOPS, right? What is the difference between RAM and disk? First of all, one is persistent, one is non-persistent. And IOPS, which IOPS is better, RAM or disk?
RAM.
RAM. That's why we get so smooth experience, right? If this Chrome browser which I'm opening or the Excel sheet that have launched, if this would launch in database, it will not be so smooth transaction. There will be always some delay. Could be delay, 200 millisecond or 300 millisecond, there will be some delay. But since we have stored in the RAM as a process, it is so better. When we save this, some changes, when I save this, then it goes to gets saved to the disk. If I don't save it, it will be in the RAM. So we cache things. We have in-memory database also to caching to improve the performance. We have AWS has options of elastic cache and memory database for Redis. Document database. You might have heard about Mongo database. So we have document. If you need some information to be stored in a document manner, JSON format, we use document DB, like all the product informations, content management, catalogs, user profiles. You have this kind of information. We use document database. And AWS has document DB, which is compatible with MongoDB. Wide column database. These are very standard. Depending on my requirement, we will select a database. We have wide column database. High scale industrial apps for equipment maintenance, fleet management, route optimization. So we have key spaces, which is basically the Cassandra. In the key spaces, AWS offering, but Cassandra is the free, like Cassandra database. You might have heard of. Facebook uses Cassandra database. We have graph database. for fraud detection, social networking, some sort of relation between the users. We use graph database. We have time series database. We use, friends, for the metrics collection, right? I showed you CloudWatch, right? CloudWatch collects metrics. So where do you think all the metrics are being stored? Must be stored in a database. We can store that in relational database also, but there are some time series database like Prometheus, InfluxDB, like in the open source in the scenario in the open source platform, you have Influx or Prometheus. You might have heard of these things. So Amazon has time stream database, like this offering of managed offering, which is very much similar to Influx and Prometheus time series database. So even our CloudWatch uses time series database, this Amazon time stream, to store all the data, all the metrics information. They're optimized for metrics kind of storage data. Ledger database, we have system of record, supply chain, registrations, banking transactions. When you have to do this, you need ledger kind of database. They are very much optimized to store these informations, and AWS has offering of QLDB. So AWS has offerings in all the requirements, in all the use case, whatever the use case you have, AWS has a offering. You have various other offerings also. If you talk about in memory, we have Hazelcast. In the document DB, we have MongoDB. These are AWS offerings. But if you talk about the open source, we have Hazelcast here. We have MongoDB here. We call it RDS, but in the open space, in open source, we have MySQL we can use. Postgres, they are open source, but AWS has used those things and managed database. They have created it. So as a user, we don't need to do a lot of things. The installation has been taken care by them. So for various things, friends, we have AWS offerings. Is this diagram making sense to all of you?
Yeah.
Perfect. Now, friends, we'll try to understand this. There are two more concepts that we want to learn. Then I will give you a demonstration of the RDS. Two more things. Now, what do you think? How AWS takes care of high availability? Let's say you have a master database. You created the master database. The reads and writes are happening there. Do you think that what will you do if that master database goes down? Like in the auto scaling we talked about, right? If the web server goes down or the app server goes down, you have multiple instances of the web server, multiple instances of the app server. We don't have a single point of failure, and if even the load increases, the web server will scale out, app server will scale out. We discussed about all the things, but how these things will work in a database? What do you think? What do you think, friends? Let's hear it from you first. What's your thought?
Replica.
For which
Database
one?
replica.
For high availability or for performance, for increasing load? What do you think?
Yes,
For
high availability. We would have
high
replica.
availability, replica you want. So you want to maintain two databases at the same time, both up and running.
Yes.
Because you have to maintain the replica also. You have to, so you want to maintain two databases at the same time, and you want to replicate the data, one database to other database, right? Because if I am placing an order and if that order ID gets stored in one database, you want that order ID to be replicated to other database also at the same time. And both should be operational. You see, so where the write will happen in any database, Because the read is not the problem, the write is the problem. When updates happen, could be insert, updates, deletes, which database the write will happen?
Primary database.
That's what, right? So you are not making it clear. You have mentioned there are two database, primary. Both are you calling it primary, right? One is primary, one is standby. What do you think? You are thinking correctly. I just want to correct your thought process. Go ahead.
I mean, like whatever the updates that comes, it will done in batches, like batch processing.
That's that batching and all I'm not talking about. Where
It's
the
not-
write will happen. Simple question.
Primary database will happen in the writes
So
will
both are
happen in the
not
primary.
primary. Both are not primary.
Both are not primary.
One is primary. You're saying one is primary, right? Okay.
Right.
Let's call one as primary. Perfect. Primary database. The read and write will happen here. Primary. And one is standby, you are saying. This will not
Right.
be operational, right? This will not take the request, correct?
Yeah, this will not take place.
That makes sense now. So because that's the problem. No, now one of the important things that we should do, let's say you have app server on top of it. Let's say you have app server on top of it, and this app server is talking to the database. Primarily, they will talk to primary database. All the read write, they will do it here to their app servers. And when they are doing anything, we have to replicate synchronously. Yes or no? Because if this is a standby database, if this goes down, I want immediate connections to be routed to the standby database, and this should have the same data as what we have in the primary DB. So this has to be a synchronous replication. Yes or no?
Yeah.
It has to be synchronous replication. Synchronous. We cannot delay this. This is a costly affair because we have that is how you're gonna maintain the yes, and this is how we take care of high availability. Absolutely correct. This is how we take care of high availability. Perfect. And that's what we do. Okay, that's what we do. So this is how we take care of high availability. You have a primary database and master database. We call it standby database. And all the requests will go to the primary database. And if this database goes down, the request will be routed to the standby database. And it has the synchronous replication. Synchronous replication.
Roshan, what do you mean by synchronous replication?
Okay. Let's say you place the order in Flipkart. Okay. Let's say your order ID is stored in the primary database, correct?
Yes.
Now let's say that database goes down.
Okay.
And let's say you logged into your Flipkart profile and you search for your order ID. Do you expect the Flipkart application to give you the order ID details? Yes.
Yes.
You have placed the order, you got the order ID. As a user, we are not bothered, right, with the database going down or not, but we will expect the order ID to be displayed.
Yes.
But the primary database is down. So synchronous will make sure it is immediately being reflected here. Synchronous. Immediately your order ID, whatever you are doing, saving it in database will be copied here immediately without any delay. That's called synchronous replication. We are replicating things, but synchronously, immediately, without any delay. As soon as you update here, it will be updated here. So as a user, you would not even realize which database you hit. You hit the primary or you hit the standby. It's not of our concern. But it has to be synchronous. Can we delay this process? Tell me. Think about it.
No, we will lose our customers.
Right? Or customers had done the order and he went to check the order and order ID doesn't exist. So we cannot delay this process. It has to be synchronous replication. That's the meaning of synchronous. Now, this is about high availability. Now, what will you do if the more load comes to the primary database? Let's say you have this setup, you have taken care of HA, high availability, you have taken care. But what would you do if the more load comes to the primary database? What would you do?
We will redirect the additional requests to the secondary database.
Can repeat that part. What would you do?
They redirect more requests to other database.
Another database, you're saying you mean to say you'll create another database?
We have
Yes.
two databases, no? Primary
Not
and
do, but standby is just for the backup thing, right? It is not active. Just now we discussed, right? It is not active. Only one database is active at one time. This is standby. In case this has problem, the traffic will be routed here. But this is getting more hits. The reads and writes are happening more here now because of additional load has come in. So what would you do in this scenario?
Use
Either we
load.
can increase the capacity of the database, or we
Yes.
can create a separate exact configuration database, another database.
So will you do write in that database also?
Yeah.
Again, because when you do the write, you're complicating stuff. So you are saying you will write in other database also. You will create another database. I'm okay till this. You can create another database. I'm good with this approach. Secondary database. But will you do write here also or here also, both? Then you're hitting both database at the same rate.
No, we will not hit the database which has more number of requests, because it anyways will be taking more time to.
No, you're not answering my question. See, this database was loaded. More hits was coming in, read and write. More hits were coming. Now you told we create another database.
we
Now my
will only do
question
read
is,
operation.
come again, Supriya.
We will only do read operation.
Perfect. We will segregate the read and write. Absolutely. This is the way to go forward. We cannot do write in both. Okay, it will do both. It will do write to read, write to both. There will be problems. We'll only segregate the read calls here. Let the write calls happen here. Only the read call we will redirect here. And we will identify. So read call will only happen here. And this need not be synchronous. It can take some time, but it need not be synchronous. See, let's say you know that what causing the additional load. You should know that. Let's say some reporting server. Let's say some reporting module is doing a heavy read calls. Select star from big table. It's taking a lot of data, a lot of time to retrieve all the information. So what you can do anyway, those are not mission critical. I need not be synchronous there. So even if only they're using for read, why can't I just redirect those heavy read calls to a separate database? So I'll create a read replica. We call this read replica. So we'll create a read replica. Exactly same data. Replica of this guy. And read replica means we'll only rewrite the read calls. Write will happen here. Write cannot happen to both the database. Write will continue to happen here. We are only diverting few read calls, heavy read calls here. Like few percentage of read calls here. The write will continue to happen here. So in this way, you are offloading this guy, right? That is what the concept of read replica we use. So we have a concept of read replica. So we create the read replica, and this need not be synchronous because this is used by some reporting application server or some reporting server, some business intelligence reporting server, some reporting, and they're putting heavy load. Need not be synchronous, could be asynchronous. And we only do the read operations here. And this way we'll be able to offload this guy. We'll be reducing the load on the primary database. Sounds good. These two options, high availability and read replicas, what we do. This could be one of the interview questions. What would you do for the performance point of view.
Sir, one query. Can you please go to that previous slide where you draw that DB? So here I'm just means getting clear. Like here we will create three databases. One will be the primary, and one will be the standby, and we will
This
create
is,
one.
you understand, this is subject to your requirement. If you have problem,
Yes.
this
Means
is
in
not
this
mandatory.
condition.
Go ahead, complete your question.
Yeah. So in this condition, we are using only means diverting our request to these two DBs. Like one is only for read calls, and other will be read and write. That primary DBs, and standby we will not use. We will use for the.
Correct.
Okay.
Only in case primary is down, then only standby will be standby will replace the primary.
Understood.
I have another question. Like, if there is no writes in the RAID replica server, like if I wanted to pull the information which is not stored in RAID replica, then how would I get that?
No, it
Get
will
that
be there,
information?
right? That is the, it will be replica of this. It is a
Okay,
replica
it
of
is
this.
just that we allow only read calls, not the write
That's it.
calls.
That's it.
Okay.
It's a
It is
replica
also
of
the
this.
replica of the primary database, but only
Exactly.
for read calls. Okay.
Read calls. It's a replica.
And
That's why the name is read replica.
okay, if that is not synchronous, then it will take some time to get the response,
Reflect.
right?
And that's why we should be very careful what traffic, which read call we are diverting.
How do we segregate that?
No, in the code, we will have to mention, right? We should know which application need not be synchronous, right? Which call could be synchronous. For example, the product information. Let's say I'm go to Flipkart page. The product information could be some delay, but the order ID, if the user wants to get the order ID, that I cannot delay. I have to get the read calls from here. But if I somebody doing the search, I can divert those calls, the read calls.
Okay, got it.
So the data which is constantly being updated, I will do the read calls to the primary database also. But once stored, they are not frequently being updated. I will divert only those read calls to this guy. Clear? Everybody on the same page?
Yes, sir. Yes.
Yes, sir.
Okay, friends, let's do some demo now. Okay, let's go. We'll create a database now. I'll go to the relational database. Okay, let's create a RDS. Let's go to databases, create a database. Let's select any MySQL database. Okay, let's say we have all the options. You can select, let's select MySQL database. I can select the options from here, which all I want, best version, whatever version. If I want some extended support by AWS, they can also enable it. They will charge us by you consent to bring charged, you being charged the offering for running your database major versions. So you can just mention extended version. You can optional options are there. You can take AWS support also. There will be point of contacts in AWS team. If you have running into issues, there will be some principal engineers you can work with. You need to select which thing you want, production, dev, test, or free tier. Production has a lot of options. We'll see the options in the production, but we'll select free tier and create database. Again, we just click off the option. We have three options: multi-AG DB cluster deployment. So this will create one primary and two readable. Mostly we go with high availability. Read replica we will create later if we need it. So second option is better. Primary, one standby. In AZ1, AZ2 we'll create this. We don't want to get the same primary and database in the same AZ. We don't want that. If that AZ goes down, we will not have the standard database in the same AZ, right? So for HA, since we're doing it, we'll keep it this another different AZ, not in the same AZ. So we'll select this option. Read replica we can create later also if we need, if their requirement. We'll give a database name. Now, only thing with managed database that we don't get option to the file system. We will not know. We will not have access to the database server EC2. You will not see EC2 instance being created and install database. No, they will manage it. We don't get access to file system. We would not know where database is installed. They would manage it. AWS would manage it. So we don't get access to the file system. That's the only thing with the managed database, because they take care of availability and they would not give us the access of the file system. But there are options to query it, to check the logs. They have all the things to uh, they have taken care of all these things, but we would not be able to SSH because we will not have any server. They would create it and they would manage it. Let's say admin, I want some password to be set. I can set some password, let's say. Some password I have set. Give the same password. Now I need to mention what should be the core and the RAM I want. Usually we give more memory to the database because when we do select query, it takes a lot of memory. So we usually go with memory optimized classes. We select this and we go with 2 vCPUs, 16 GB RAM, or 4 vCPUs, 30 GB RAM, or 8 vCPUs. So mostly these are the two ones. 4 vCPU, 30 GB RAM, or 8 vCPU, 64 GB RAM are the most preferred ones. Takes more memory. Mostly we use the memory optimized. We want more memory in the database. So we can select any of the options here. Storage, we can give how much storage we want, and 400 GB, and IOPS. We can also change the IOPS. We can select. We have the options of GP2, GP3, IO1, IO2, and whatever we select, we get the better IOPS and we get the better performance. Right? So we can select these things, GP2, GP3, whatever we want, we can select it. If I select GP3 and look at this, we have the options of IOPS. If I select IO1, we have better options of IOPS. So we can select, depending on my requirement, we can select which EBS volume we want here. Auto scaling enable, so you will never run out of disk. So if let's say you started with 200, 400 GB and you selected this and you mentioned one, I can go up to 1 TB also. So we check this option. Automatically, they will make sure you never run out of disk space. Automatically they will take care. If you manage it on-prem or in a EC2, you have to make sure you have enough disk EBS volume. But in managed database, they would manage it, right? And they would do auto scale on the storage also. We have, and for connectivity, if I want, so usually we need to connect to the database, right? So we connect to an EC2 instance so that you have a server to connect to the database, because we need to install the client, because we need to query the database, select star, insert. So we usually connect to the EC2 instance. But for this example, I'm just showing you, I'm not connected to EC2. I'll directly connect to the database. But in a real example, we always have a EC2 instance where we install the client and we connect to the database and we do queries, right? We need to do inserts, operations, select queries. So we do that. But in this example, I'm directly connected to the database. We never give public access to the database, never ever. And we select our own VPC, private VPC, like our own VPC, our own private subnet, we will create it. But I'll use the default ones because I'll show to that how do we connect to the database. I'm not going to show you how do we install the client and all those things that you can do that. I'll make it public access and I'll show you how do we enable the public access. But in actual, we create the EC2 instance, we install the client there, we install the database in the private VPC, we connect to the server, right? And then we access the database, select queries and all. We do all sorts of things. Public access, we don't enable it, but we'll enable it for now, this case. That's it, friends. We can have the monitoring. If I need better insights, we can have monitoring in place which query taking time and all those details. Every insight is available. Okay. how my database is performing. Every insight is possible, and we have to just pay some amount, what type of log we want. I would like to capture all sorts of logs, and we need to pay some amount monthly, and that's it. Create database, and that's it will be done. We will not create this. I just showed you all the options, but we'll use the free tier. Free tier, we don't get these two options, we get only these options. Okay. In free tier, we only get 2 vCPU, 1 GB RAM option, burstable class. We don't get memory optimized class. We only get GP2, 20 GB. We will not enable auto storage. We don't need. We'll make it public access only, but we will actually involve. We will not do. We can select security group. By default, we have given. We can mention 1A, 1B, 1C. Let's say 1A. Database insight standard, we will get all sorts of enhanced monitoring. We can get it. We can select it for the enhanced monitoring, and it will be free tier. You can also use free tier. You will not get charged. Create database. So it will take 10 minutes and it'll create a database. That's it. We don't need to worry about anything installation. So MySQL will be created. Database will be created in 10 minutes. We will all the monitoring, if you go monitoring, because every service in AWS is integrated with CloudWatch. You will see all the metrics here in some time. All the logs, you can get it here. Okay. If you need any actions, let's say later you would decide to create a read replica, you can create it. You want a blue-green deployment, you can do this. Take a snapshot, do it. Point in time, you can do it. All the options, reboot database, delete database, set up EC2 instance, Lambda connections, everything is possible in your database. Let the database be created. I'll show you how do we connect to the database. And it's being done in automated fashion. Okay. Let's wait for a few minutes, friends. Take some time and my database will be ready. We will use a client. As I told you, we will not be, since we are not setting up an EC2 instance for this database, we'll be publicly creating it, publicly accessing the database. You'll get the endpoint here. Okay, and we can correct EC2 instance later also. Everything could be done later. Let the database create. You will see all the options will be ready, available. It lies grayed out now. It's disabled, but as soon as the database will be ready, it's getting created. Okay, they are creating it. So we have given all sorts of things. We just click, we get high availability. We just convert to multi-AZ. That's it, done. With one click, we get these options. These are the offerings. But if you have to do this yourself, let's say in EC2 setup, you have to create another database. You have to set up synchronous replication. All these things you have to do it. But in managed database offering, AWS is going to do this on your behalf. Everything is automated in this case. High availability, creating read replicas, database migration from your taking like creating a read replica, everything. Now my database is ready. Look at this. My database is ready now. Look at this. And I'm getting the endpoint connection. We can connect to the database using this. And if I just show you, we have all the options available now. We can go to multi-AG deployment. You can take the snapshot. All the options are there. Since we are using some free tier database, we don't get options. But if you use a production level database, we get all the options. Now let's connect to the database and show you. In the monitoring also, let it take time, and all the monitoring will be ready here. CPU, connections, database connections, CPU utilization, disk queue length, all the metrics is available to us. And you want to know about the query details, you have to enable performance insights. And you get query level details, which query is taking longer, what is the wait events. Like if you have looked into AWS report of Oracle, you get all the details there. Similarly, you can get the details here in a graphical manner. Very beautiful details, all the details you will get here. It will take some time. For the free tier, it will not get enabled. Okay, you will not be able to see those details. We need to wait also, we need to enable also. But let's connect to the database first. Let me show you how do we connect to the database. So we need the client. We need the client, and we can use this connection database endpoint port and the username and the password that we have set to connect to the database. So let's use a client called SQL Electron. Any client, you can use a lot of clients available. I have given you the link of SQL Electron here. This link. If you go to this link, you can download this. It's just a client. It will help you connect to the database. You can download the GUI, and you have just download this. This 1.38 Windows, Mac, whatever DMG Mac if you want. So I have it downloaded in my downloads. If I just search for I have a SQL Electron. If I come here, friends, you can download this, and you just need to open this guy, application part. Once you download the same thing, once you download this as a win.zip or win.jz, once you download this, you extract this, and you'll get like this, and you just open it. It will open the client, and you will be able to connect to the database. But actually, in actual, you will not do this. You will set up the EC2 instance. You will connect to the EC2 instance. You will install the client there, and then you connect. You do this connection. Okay. So there's some different way. I'm showing you publicly just to show you. Okay. But in actual setup, we don't create in the public subnet. We don't give SSH access. We don't give internet access to all these things. I'll connect to the database. I'll add a database entry. I'll give a database name. It's a database. You can give any database. I call it ESR database. It's ESRDB. I can select multiple database options we can have. Let's say MySQL I want. Host. I need to give this host endpoint. 33 used by port by default. Admin is the username that we have given, and the password I have set was this. I can test the connection. Looks good. I can save it. ESRDB, I can connect to this. Let's look at. I got connected to the database. Now, if you know some commands, so databases, some SQL queries. If you are comfortable with SQL queries, so databases. You look at. I'm executing this. You can create a database also. Create database if you want. Say SREDB. If I so a database now, you will see the file database. So it's SREDB. You can go to SREDB, use SREDB. And you can insert, create some columns, upload, and all those things could be done. Okay. Okay, you can just SQL things, you can do this, friend, and you can just access your database. What I want to show you other options. Okay, now you can do SQL queries and all. I'm not going to talk about that. In the monitoring, Because you don't have access to the file system. You can say, Roshan, we don't have access to the file system, and how can we see the logs and things like that? I showed you the monitoring part. We have a lot of options in the monitoring part. You can see it will give it this some time. It will give a good graph for you. Give it some time. Okay, it will come up. Good graphs and all. You can see some dots have come. It will come up. You want to check the logs? Go to logs and events. So you can capture the logs. Look at the logs. If I just open the MySQL error logs, I can just check the logs. Look at this. So they have the server. Only thing that we don't have access to the server. But if we need to check the logs, we can check it the logs. We have all the options. I can download the logs. I can watch the logs. I don't want to just keep seeing. I just want to keep on watching the log. Whatever the log entry will be there, if you're having issues, you can come to the log part and see what is the error you're getting. From this error message, you can understand what could have been going wrong. Okay, so you have the log place here. You can come here and check configurations. You can see all the details here. What are the configuration I have? You can take the backup. Just take the backup, take the snapshot any point in time. Now it's enabled for 1-day backup. Automatically 1-day backup will be taken up here. I don't need to worry about it, but if you want to change the frequency, you can change that also. Okay, to hourly basis or whatever you want. They will give you some recommendations if you're not following some guidelines. Okay, they will give you some data, so they will give you some recommendations also. If you want to migrate your data, you can also do that. So a lot of options you have it. Okay, friends. All the metrics you can see. CPU, I want to look at the CPU utilization. Check this, CPU utilization is here, 15%. I want to check the connections. Database connections is here. I want to check the throughput. Select throughput. I would like to say select throughput, read throughput, write throughput. Latency, I want to check latency, read latency, write latency, read latency, write latency. I can check all the details. All the metrics are available for me. So they are important metrics, right? The CPU, the connections, the throughput, the latency. They are important metrics. Queue depth, to show you what's the number of process being waiting. So you have these important metrics. You collect this. You want to check about the SQL tuning, SQL, which SQL taking time. Again, performance insights will be helpful. You need to select your database here. It's not coming up for the free database insights. So on November 30, a major RDS will no longer support the performance insights because they are consolidating everything to the CloudWatch. They're telling, okay. It's not coming up because of the free tier we have selected, and anyway it will be discarded post November 30, and everything will be part of CloudWatch because they are just clubbing everything. They just want to make one tool for everything here. APM tool, want to check database insights, Lambda insights, want to capture everything, have the dashboards ready. They would have all the things, insights, database insights will be coming up here. You can also check the database insights. I have one database here. I can select the database. Whatever database I have, I can, if you write the query, database one is not onboarded to database insights, I can just onboard also right now. Let's not do this. Okay, a database telemetry, performance analysis, we have all sorts of things. Very good. So AWS provides a lot of such services to get the metrics. One place, CloudWatch is going to be the one place where you have all the details going forward. APM details, database insights, container insights. We'll talk about that in the containerization from the next week. Networking monitoring, APM tools, metrics. I have already showed you metrics, and you can check the logs, flow logs, and application logs. Okay, friends. So that's all I wanted to cover in the database. It's making sense, all of you? Why do we use a database? What is relational database? What is, first of all, cloud managed offerings? Did we understand this? Cloud database managed offerings. Did we understand that today?
Yes.
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 Perfect. Good, friends. We'll talk about containerization. We'll start a new topic, containers, Docker, Kubernetes from the next week. Okay, that's all, friends, for today. Make sure you delete the database. You can practice it on your own, ask questions, and make sure you delete the database. Okay, come select the database, actions, delete. Look at that. I can create the read replica right now. Even now it's being stable now. Now I can just create the read replica. Every options are enabled now. I can reboot it, delete it, set up the EC2 instance, Lambda, anything I can do. I can create a the caching. I can cache the database. I can have elastic caching. Delete it, friends. Okay. Don't take the snapshot. I don't want to take the snapshot just for the demonstration purpose. I don't need to take the snapshot, but it's a real thing. I'll take the snapshot finally. Delete this. That's it. Done. Okay, that's all, friends, for today. We'll meet next week and discuss on the containerization. Thank you so much.
Thank you. Thank you.
Thank you. Thank you.
Thank you.